So let us in this welcome back guys. So in this class we just solve one block reduction problem. So I already said that. So why we need the block reduction? So this is one system. So we need ultimately C by R. So response C of S by R of S is our transfer function. Okay. So that means this whole individual subsystem blocks I need to get each one block, that is G block, let us say. Okay. So for that, what we need is block reduction techniques. So we have seen rule 1, 2, 3 up to 9 rules how to reduce the block. So we'll just use that all the sources what we need, learn about the block reductions, and will that solve our problem. So if you see, observe here carefully, I want to submit up all these blocks into one single block. For that reason, what the rules I'll use. So if I see carefully, I have seen the blocks. These two blocks are in cascade form, that is in series form, and these two blocks are in parallel form, and this I'm seeing a minor block here. So individually C1 G4 and this minor block here, and again if you do continuously we'll see minor blocks. So first of all, let us reduce these two blocks, this G1 G2 which are in series, into G1 into G2, and this G2 G3 which are in parallel into G2 plus G3. So let us solve that initially. So just I'm drawing the system. So G1 plus G2, so G1 into G2 which are in series, I'm giving G1 into G4, I'm giving one block. Okay. Now these G2 and G3 are in series, so I'm giving G2 plus G3 and one block. So see carefully, this takeoff point at this point, this is not interlinked with the summing point. So this is the takeoff point. So you need to know what is the takeoff point, what is the, so this is the takeoff summing point, and this is the summing point. Here we have takeoff point, here we have takeoff point. Okay. Now G2, G3 is given, and again, so this is continuous, and so we'll close this loop, feedback loop here. So I'm having a positive feedback here, and again another feedback, that is H2, which is getting here. Okay. Now my next talk is, I'm seeing this is a minor block here. So I want to reduce that minor block into one block. So what I'll do? So I'm having a minor block here. So I want to reduce that. How I'll do? So this is the fast feedback. So we have if we have a function, so G of S, so I'm reducing that block like this. So G1 G4 divided by G1 plus, so 1, so here the positive feedback, so that's why I give 1 minus G1 G4 H1. Okay. So I just reduce this whole I reduce this minor block like this. Okay. Now I'll continue my journey of reducing the feedback. I'm giving G2 plus G4 as normal one, and again I'm closing this loop H2. Okay. And I'm having a feedback of negative feedback. Now again, these two are in which form? Whether in series or parallel. So these two are in series form. So with this series form, you have G1, G2 in series form, we'll multiply that. So I'll again multiply these two blocks. Okay. So G1, G4 divided by 1 minus G1, G4 H1 into G2 plus G4. Okay. And this is one block. Now I'm having again feedback H1, sorry H2. So I get again what? One minor block. Okay. So again I'll reduce this minor block into one form. How I'll reduce? So directly I am giving this one minor block here. So G1 G4 by 1 minus G1 G4 H1 into G2 plus G4. So divided by 1 plus G1 G4 divided by 1 minus G1 G4 H1 into G2 plus G4 into H2. Okay, this is G of S, this is H of S. So now what I did is G of S 1 plus G of S into H of S. That's it. So again we will further multiply this. We'll get G1 G4. So this G1 minus G1 G4 H1 will get cancelled. So G1 G4 into G2 plus G4, G2 plus G3, sorry. So here we have G3. So G3 here, G3. So G3, G3. So 1 minus this gets cancelled. Now 1 minus G1, G4, H1 plus G1, G4 into G2 plus G3 into H2. So you further multiply this, we'll get, so H2, so this, so 1 minus G1, G4, H1 plus G1, G2, G into G3, G3 into H2. So this is one final block for whole system which we deal. Okay, so this is R and this is C. So C by R means this whole block will come. Okay, so this is the final block for the system which we discussed. For this whole system, this is the final. So this is the final block we'll get, okay, by using block reduction techniques. So in the next class, we'll deal another techniques, that is Mason's gain formula. So by knowing that Mason's gain formula, we have the technique called signal flow graph. So what we'll see how to represent the block into signal flow. By using the Mason's gain formula, we'll reduce the transfer function of big system into a small system. Okay, thank you.